In this video, I will try to discuss the design method for reinforced concrete. So, reinforced concrete design is controlled or specified by American Concrete Institute. It is simply called ACI, American Concrete Institute. So, American Concrete Institute, they control the design of reinforced concrete design. So what are the methods? There are the methods. First one may be WSD. WSD is working stress design. Other is USD, ultimate strength design. So these are the two common methods or two popular methods. One is WSD. Working stress is very old. Very old means it was it started say early 90s, and this one started 1956. So ACI adopted USD method 1956. So after 60s people started to forget this and adopting this. Even at current days, now it is 2020, so I do not think anybody in this world use this method. So we will learn USD is ultimate strength design. In reinforced concrete design we call USD method. The same method, but we use different names for steel and wood. In steel and wood, we use LRFD. LRFD. Load and resistance factor design. Actually, same method, different names. ACI use USD. AISC, American Institute for Steel Construction, and Wood Design, American Wood Council for wood design, they use this name. So actually same concept but different names. So if you hear about USD, LRFD, it's same thing, different names. In fact, this name is better because it represents the concept better. Okay, we'll see. So I will very briefly, what is working stress design? Although we do not use it, but just to know, because we use this concept in our daily life. Say the capacity of a cable. A cable can take 20 KSI load. You tested a cable in laboratory, pull it, and it failed at 20 KSI load. So this is its failure stress. But we'll divide by a factor, by 2, 3. That means if I use a factor of safety 2, then the failure stress or failure strength of this cable is 10 now. 20 by 2 is 10. So the capacity is 10 now. Now, then we can use this cable anywhere in a structure where the stress is not 10 or less. So the stress is 10 or less, we will use this. That is this method. So what we do here, whatever the capacity of the material, we divide by factor. So it is not economical because we do not use the full strength of the material. Okay, this one, what we do here, USD is ultimate strength design. The concept of this method is what we will do, we will use our safety in two ways. Number one, whatever the capacity of this material, say if I take it to laboratory, test it, and fails at 20. Say, okay, then let us give a name. Say I took a beam sample to a laboratory, tested it, and it failed at certain moment. So this moment, and this N means nominal. So moment, and this means nominal. So nominal means theoretical or tested. Whatever is actual in the laboratory, that is called nominal. Say the nominal moment capacity of a beam is something is So what we will do? We will multiply by a factor, that is called uh, strength reduction factor. So this is called strength reduction factor, and that is roughly 0.9. But do not memorize this number. Do not memorize this number because this number changes. We will discuss it in our next video. So, but roughly 0.9, say for moment it is roughly 0.9. That means whatever the capacity of a member per moment, that is per nominal capacity or nominal strength, we multiply by a factor. Okay, this is one way. So you can see here resistance factor. Resistance factor. Now what are L? Load and resistance factor. Now we will see load. Then what we will do? We will calculate the actual moment. The actual moment in this beam. Say the beam is this. It is 15 feet. Our dead load say 2 kip per feet. Live load say 3 kip per feet. Hopefully you know what is kip. In short we write K per feet. A dash. Typically we use this right in our design. So dead load 2 kip per feet, live load 3 kip per feet. What we will do? We will increase the load by factor. And that factor is another discussion. ASCE, American Society of Civil Engineers, they gave us a set of factors, 7 combination. It is 7 combination. If you saw somewhere 7 combination, depending on the load. But that is a different discussion. But I can memorize that if the load is only dead load and live load, my factor for dead load is 1.2 and factor for live load is 1.6. So we will increase the load by factor. So 1.2 times 2, 1.6 times 3. If I do the calculation, 1.2 times 2 is 2.4, 1.6 times 3 is 4.8. So 2.4, 4.8 is roughly 7.2 kip per feet. Hopefully it is correct. Then we will calculate the moment. And this moment we call MU. MU, factored moment. Is factored. Why? My load is factored. Then if I do so WU L square by 8. Now what is WU? My uniformly distributed load we represent by WU. W, uniformly distributed load, is by W. U means ultimate or factored. So U means actually ultimate. Ultimate. So U means actually ultimate. Other name we call it factor. So W square by 8. If I analyze this beam, that is the maximum moment equation. So 7.2 15 square, 7.2 15 square by 8. That is in kip feet. Now, what is the design? That this is the actual factored moment in my beam. This is the capacity. So the design is that this capacity must be greater or equal than this moment. That is the USD method. USD or LRFD, load and resistance factor design. Where is load factor? Load factor is here. Where is resistance factor? Resistance factor is here. And then factor design. So this is the concept of USD or LRFD. Now I just name here moment. If it is shear, then shear. If it is axial force, then axial force. But the concept is this, that whatever the capacity of my section in laboratory, I will multiply by phi and decrease it. Then whatever my actual load in my structure, I will increase it. Then I will compare. So here my design safety is I am adopting safety in 2 ways. One is I am decreasing my strength, other is I am increasing my load. Then I am comparing, and this portion is called nominal. After multiplying this, it is becoming my design design moment. So be careful in question in a RFE exam or whatever, the PE exam, whatever. If this is nominal, that means this. Nominal means theoretical, whatever you get in your lab. And if after multiplying by phi, it becomes the design capacity. Now in your member, after applying the factor, and if you calculate the moment, it is ultimate moment or factored moment. If you calculate the share, it is ultimate share or factor share or design share is. So these are the design or factored or ultimate. This portion is small portion, mn, is nominal. So hopefully you understood what is nominal, what is factored, and what are the design system. We will continue in our next video. We will start the designing equation for reinforced concrete design. Thank you.